Service. I'm Orpheus Praxis. Welcome to my channel, where modern physics gains a new sense of wholeness. Today, I'll show why the cosmological constant devised by Einstein might not be needed at all. Einstein introduced Lel to keep the universe static. Later, with the discovery of expansion, he called it a mistake. In the 90s, acceleration brought the constant back as dark energy. But what if dark energy isn't a mysterious external force at all, but rather an inherent feature of the cosmos itself, embedded in its very structure? I see the universe as a three-dimensional, simply connected compact manifold, a seamless sphere with a trivial fundamental group, infinite in its essence. This is not just an abstract shape, it is a system in which energy is channeled along fractal spirals, much like the elegant arrangement of sunflower seeds in nature. In this vision, every element from relic radiation to black holes is governed by these spirals, creating a natural order that many modern models have struggled to explain. Let's dig deeper. The relic radiation, the cosmic microwave background, CMB, is replete with wrinkles, anisotropies with an amplitude of delta TT 1010, which we measure using instruments like Planck and WMAP. These intricate patterns are more than random noise. They are the footprints of energy flowing along these spirals, reflecting the quantum fluctuations from the earliest moments of the universe. While the standard LCDM model attempts to explain these anisotropies, it often falls short in fully accounting for both the observed singularities and the fine structure of the CMB. Modern models, in many cases, cannot robustly account for the subtle irregularities we see. They miss the inherent fractal logic that seems to underpin cosmic structure. In my model, the energy density, a value of about 8.10 kilograms per kg today, is not distributed uniformly across space but follows these fractal spirals. This uneven distribution gives rise to both the colossal structures of galaxy clusters and the tiny grains that pepper the sky, offering a unified explanation that bridges the gap between quantum scales and cosmic scales. The sphere grows according to the rhythm RT equals R res C E square H T minus T rec, where H is the Hubble constant, R rec is the radius at recombination, and T rec is the recombination time. This post-recombination expansion accurately captures the observed acceleration. While the total energy remains conserved, its density diminishes as the volume increases. The natural pressure of light within the manifold pushes outward, creating an acceleration that modern LCDM models often attribute to dark energy. Instead of invoking an inexplicable force, this model shows that the expansion is a direct consequence of the geometric distribution of energy. As the sphere enlarges, the resulting decrease in density sets the pace of time and injects a dynamic complexity into the fabric of the cosmos. But there's more to this story. Black holes, rather than being mere endpoints of gravitational collapse, emerge as critical nodes within this spherical structure. Inside these nodes, light is caught in fractal coils, a mesmerizing spiral dance. However, energy is not lost. It escapes as heat at a temperature given by TH equals chi pi c Cre 8 pi g mkb, or manifests as subtle fluctuations in space itself. This phenomenon, often observed as Hawking radiation, is a natural outcome of the manifold's dynamic pulsation. Here, the energy density does not simply vanish, but cycles through different modes, reinforcing the notion that singularities and anisotropies are intrinsic to space's fractal structure, a nuance that conventional models like LCDM have difficulty reconciling. Moreover, the cosmic energy density flows along the same fractal spirals that sculpt the CMB. This elegant pattern explains why galaxies gather into vast networks and why we detect fine-scale temperature fluctuations in the relic radiation. Modern cosmological theories frequently grapple with anomalies in the observed anisotropy and struggle to account for the singularity at the universe's origin. In contrast, this revolutionary model naturally incorporates these features, reflecting the harmony of a sunflower's seed pattern across the cosmos. The very beauty of this approach lies in its simplicity and depth. The cosmological constant becomes redundant when we see that the pressure of light, arising from the intrinsic fractal distribution of energy, and the expanding sphere itself create the observed phenomena. This model lives and breathes through observable quantities. It explains the CMB anisotropies with delta TT 10 main and C, the energy density measured at 8.6 times 10 squared kilogram meter spheres, and even the subtle wave phenomena around black holes. These are not merely fitting parameters. They are emergent properties resulting from the underlying geometry of a universe that modern models have yet to fully decipher. This is not a hypothesis born of speculation. It is the logic of space itself. In my vision, space is not a passive stage for matter and energy. It is an active, dynamic, and beautifully ordered manifold where light and form merge in a continuous expression of energy. My conclusions, drawn from both theoretical insights and observational data, align with what we see. The detailed patterns in the CMB, the clustering of galaxies, and the energetic behavior of black holes. Imagine a universe where every filament of light, every ripple in space, and every twist of a fractal spiral is part of a grand cosmic symphony. Modern models such as LCDM have struggled with explaining the full complexity of anisotropy and the singularity, issues that this revolutionary approach addresses with elegance and precision. It not only provides a consistent framework for understanding the early universe, but also redefines our grasp of cosmic evolution in a way that is both profound and verifiable. In upcoming episodes, we'll delve deeper into how these fractal spirals give rise to the intricate patterns of the CMB, why this seamless sphere explains the enigmatic properties of black holes, and how it offers a radically new perspective on the beginning of time itself. We will explore the detailed interplay between quantum fluctuations and geometric order that ties together everything we observe in the cosmos. Subscribe to Orpheus Praxis, because we do not chase fleeting theories. We return to the timeless logic of space. Together, we'll journey into a universe where every ripple, every spiral, and every burst of light tells the story of a cosmos that is as elegant as it is interconnected. Namaste.